Hi, I'm Sean Vera, CEO and founder of Motion DSP. We make GPU-accelerated image processing software for law enforcement and for military applications. Today we're going to show Ikena ISR, our latest application running on the new Fermi architecture on Quadro. So in today's military environment, there is an enormous amount of video coming from unmanned aerial vehicles. This video needs to be viewed and analyzed in real time. So here's some typical footage from a UAV. And as you can see, because of turbulence, the UAV bounces around an incredible amount and you get this type of video. So in real time, this is what our software does. So you can see it's a remarkable difference, and this really reduces the workload for the person who's using the software, because for them to tell, for example, how many people are on the boat, it's pretty much a no-brainer which one you want to look at. So this is a very critical capability for them. And Ikena ISR running on Quadro architecture, we can do all of these video enhancements that are in our pipeline in real time in less than 300 milliseconds. The second example I want to show is one that uses infrared imagery. So this is an IR image taken from a typical infrared camera on the ground. And as you can see, there's a great deal of noise. And so let me show you a split screen of what our architecture does. Now the first thing you might notice is that it's stabilizing the scene. The second thing you're going to notice is the amount of noise that's different. Let me turn off our image processing for a moment. Now you can see all of this noise that's going on in the scene. Now, if I turn on the super resolution reconstruction, you'll see that all that noise is basically suppressed from the image. So again, this is something where an operator who's trying to figure out intelligence right at that moment is going to find this type of image much easier to look at. And it's going to let them do their job a lot faster. All right, our next example is also from a UAV, and this one is suffering from multiple things at the same time. The first thing you can see if you look clearly is there are a lot of interlacing artifacts in this video. So I'll turn on Ikena's automatic deinterlacing function, which does a super resolution based deinterlace, allowing those two fields to be fused perfectly together. The next thing I'll do is you can notice that this video is very much overexposed. It's too light. So I'll turn on Ikena's automatic contrast and lighting adjustment. So now this video is well exposed, it's deinterlaced properly. Now, of course, you see two other problems. A, the camera is bouncing around a lot. Let's stabilize it. And let me just show you a split screen of the two so you can see the difference. So now that we've corrected the lighting, we have deinterlaced it properly, and we have stabilized it, you'll also see there's an enormous amount of noise. And again, this is where Ikena's multi-frame super resolution technology comes in handy. Watch what happens when I turn on the resolution enhancement. All of a sudden, all that noise is gone. So again, I'll show you before. This is the original signal coming in. And of course, I've showed you each one of these filters separately, but all of this turns on automatically when you start processing. So all the operator has to do is literally turn Ikena on, and their picture becomes this. Another thing that we can do along with fix the video, stabilize, and do all these improvements is to put the video in context. What you're seeing a demo of here is where we're actually painting what's called a mosaic in real time, where we're taking the video and we're stitching the video live together to show you a live map of what you're looking at. And this is a very important piece of intelligence for someone who's watching a UAV. And it's these kinds of very sophisticated image processing algorithms that are made possible by the new Fermi architecture and GPU. So that was a small demonstration of what we can do with Ikena ISR. CUDA was a really key thing for us because it allowed us to enable real-time image processing on video at very low latency. Now, where things are moving, of course, is HD. And now all modern sensors in use are going to both 720p and 1080p. Now, in order to process that video, takes an enormous amount of compute. 1080p video is 6 times the number of pixels from standard def video. So that's really where the Fermi architecture is taking us. It's enabling us to do this type of sophisticated image processing on 1080p footage. So if you'd like more information, you're welcome to go to MotionDSP's website at www.motiondsp.com.